about something called a precipitation reaction. So this means I have a test tube, okay? I'll put something in here that is soluble in water. So I say A is soluble in water plus B, which is soluble in water. Okay, so I'll put both of them in here. And when I put them together, I get a solid. Okay? And this solid is called a precipitate. So the key concept here is I have two things that are soluble in water. I mix them together and something crashes out. The thing that's crashing out is called a precipitate. Okay, so this is why it's called a precipitation reaction. So the Ionic equations try to help you understand what is it in that reaction that actually caused this to happen. Does that make sense? Okay, so one of the things that you need to understand is the difference between something that is a solid, liquid, aqueous, and gas. Okay, so if I have something called silver nitrate, and this is aqueous, okay, you with me? And I'm going to react this with NaCl, which is also aqueous. I'm going to get what? How do I solve the rest of this equation? Remember the rule that I taught you?
First, how is what?
Yep, so the outer with the outer and the inner with the inner. So outer with the outer and the inner with the inner. So what would that look like?
Argon and chlorine?
Not argon, this is Ag, which is silver.
Silver and...
So silver and?
Sodium.
And?
Chlorine.
And chlorine. Okay, and this is going to be S plus?
And sodium.
So which comes first? Sodium. Excellent. Sodium nitrate. Remember your ions. If you're not sure, the one that comes first is always plus. Okay? So NaNO3. And this is going to be aqueous. Are you all with me so far? Okay. Now, if you're not sure which is positive, which is negative, start here. Okay? Silver comes first. Do cations come first or do anions come first? Cations. So this must be plus. NO3 must be minus. Na is? And Cl is minus. Okay? So that's why it's outer with the outer and inner with the inner. Does that make sense? Now, to write an ionic equation, again, is to understand the difference between aqueous and solid. Anytime you have aqueous there, that means that this molecule is splitting up into its ions in water. That's why it's soluble. All ions are soluble in water. Let's write this down. All ions are soluble in water. This is important. Okay? So to help yourself out, put a line between everything that's going to split up. This is going to split up because it's aqueous. This is going to split up because it's aqueous. This one here, is it going to split up? No, because this is a solid, so it stays as it is. This is a precipitate. Okay, what about this one? Yes, so it's going to split up. So to write the ionic equation is exactly that. Break it apart into the ions where it does that. So this is going to form Ag plus aqueous. You always follow it with aqueous, that means it's soluble in water, plus NO3 minus, which is aqueous, plus Na plus, which is aqueous. Before that, Cl minus, which is aqueous. Now I get to the other side. Is this going to break apart? So I write it as I see it. It's not going to break apart. It stays as AgCl, which is solid, plus Na what? Na plus aqueous plus NO3 minus aqueous. You with me here?
Plus or minus?
You have to, because they're breaking apart into the cations and the anions that make them up. So I'll repeat. This one here is aqueous. Sorry.